Alright, so here we are with our Chapter 2, Day 2. We're talking about greatest common factoring and then also factoring by grouping. This is going to actually be our notes sheet, and then once we take the notes on it, then the problems next to it will become your assignment. So, on that, we're going to do the circled problems. So if we take a look at number 1 and 2, we're trying to find the GCF, or the greatest common factor of each of them. So when you do this, you always want to check to see if the numbers have anything in common. And then after that, you want the variables. So if we take a look at the numbers, we have the numbers 6 and 5. And so when you think of all of the multiples of 6, for instance, like 1, 2, 3, 6, and then we think of all the factors of 5, we really only come up with the same number of 1, okay? And as much as 1 is technically a lovely number, it doesn't actually help us because everything is divisible by 1. So we don't have a GCF that has anything to do with the numbers, so we've just checked. And then we look at the variable. And so if we look at x squared and x squared, clearly both of them have an x squared in it. And so we are going to be able to say that that is our GCF. Alright, in number 2, we're looking at the numbers again, and notice that we have 15 and 20. So again, if you imagine the list of all the numbers that multiply or could divide nicely into 15 and negative 20, it turns out that 5 is pretty much the only one that is going to go into 15 and 20. Again, you can make a list of all of them if you feel like it. So for instance, the number 15 has a 1, a 3, a 5, and a 15 that can divide into it. But the number negative 20 only really has 1, 2, 4, 5, 10, and 20. And so when we look at comparing them, really the number 5 is the only one that's alike in both. Alright, after we choose the number 5, then we have to look at the power, and we have to say, okay, well this one has an x to the third, and this one has an x, and you might be confused by the word greatest, and so you say x to the third, yay, done. But the problem is that you have just said that x can be divided by x to the third, but it can't because it's too small. So in that case, we're going to go ahead and actually say that our variable should always be the lowest power. Alright, so if we take the lowest power, we are in fact actually going to have x as our variable and not anything with a power. So we've basically just said that the greatest thing that can be divided into these two pieces here is going to be 5x. Alright. Then we're going to take it one step further, and we're actually going to divide out this piece. So we did kind of mention as we were doing number 1 and 2 that this is something that can evenly divide in. And so we're going to factor each expression, which really just means divide out the GCF. And then you're saying, okay, well, where am I dividing out? And so every one of these is going to have parentheses. So thinking back to when we were doing distribution, remember you had a set of parentheses and probably like a number out here, and then you distributed. We are basically doing the opposite now and undistributing. So backwards distribution. Because, of course, in math, once you learn how to do something forwards, we always end up doing it backwards then. Alright, so in that case, we're going to take a look at 35x plus 42. And so we're going to see what can divide into both of them. So just like we did above, we'll look at the number. And so taking a look at the number 35, our multipliers of 35 are going to be 1 and 5 and 7 and 35. Not much. And so when we take a look at 42, the only numbers that of course go into 42 would be 1, okay, great, but then also 7. So officially what you're going to do is realize that 7 is your GCF, and so we're going to take this first piece and divide it by 7, and this second piece and divide it by 7. Technically, the next thing I'd look for is a variable, but if you notice, the second one doesn't even have one, so there's definitely not something that's alike in both of them. And so in that case, we're just taking out or dividing out this 7 out front, and then the leftovers are going to go over here in the set of parentheses. So for instance, if you take 35 and divide it by 7, you're going to end up with 5. That x will also carry along, but then if you take 42 and divide it by 7, you're going to get 6. So this is officially, using the GCF, the factored out or undistributed version of 35x plus 42. There are ultimately more answers for what you can divide out, but if you don't use the greatest of them, it's not going to be what we call completely factored. So make sure as you're looking at this that you are trying to figure out what would actually be the complete factor or the largest thing that could divide in. One more thing that I have here is checking your answer by redistributing. So just kind of a side note here, if we had started like our previous assignment with 7 times 5x plus, that should be a 6. We would have taken the 7 and multiplied by 5x to get 35x, and the 7 times 6 to get 42. So hopefully you can see that those end up matching, right? And so that was the original problem that we're getting back. Alright, so again, if you aren't sure if your guess or what you're starting with is working, you can always go ahead and try to redistribute. Alright, our next example here is a trinomial, so we've got 3 pieces sitting here. And so same thing as having 2 pieces, you're just going to look for what's alike in both of them. So we're looking at the numbers 12, 8, and -6. The easiest thing would be to take the largest number and find all of its factors. Or actually the smallest number and find its factors. So 6, that's a terrible 6. 6 has the factors of 1, of course, 2, 3, and 6. So once we have all of those factors, we just see which ones go into the others as well. So 6, for instance, can't go into 8, 3 can't go into 8 evenly, and so the only thing that can is 2. And then we double check, does 2 actually go into 12? And yes, it does. So 2 happens to be our number that we can divide everything by. And then we look at the power of the variables. So we have x to the 4th, x squared, and x. And so looking back at our notes, we're going to do the variable at the least power. So which one of these variables has the least power? We have 4, 2, and this is actually a 1. So in that case, we're going to have an x that's divided into all of them as well. So all of those 2 x's are going to go out front, and then you're saying, well, where did all 3 of them go? Or where did the 2 7s go from the previous one? But it's not that they are gone, it's that they're undistributed. So we're taking like all the assignments back and we're making one pile. So this is the one pile of the 2 x's. Because ultimately there will be 3 of them when you redistribute, if that's necessary. So then we're going to have our trinomial sitting here of the results. So 12 divided by 2 leaves us with 6. And x to the 4th, taking away one of the x's, leaves you with x to the 3rd for the first term. The next piece you have 8 divided by 2, and so there's going to be positive 4. And then x squared, taking away an x, will leave you with an x. And then the last one, your x's actually cancel, and so you're just going to have -6 divided by 2, which is -3, and then you'll be done. Remember that you can check your answer by redistributing, so if we take that 2x and multiply it back in, 2 times 6 becomes your 12, and x times x to the 3rd becomes x to the 4th, and so you can see that those multiplying back in would actually get you back to the original question. Alright, the next ones here are going to be part of your assignment, so go ahead and do those later. Another piece is I'm going to show you an example of what I worked out here. Basically, when we factor by grouping, we're going to do what we did in the previous slide twice. So in order to do that, what we need to do is actually make this problem smaller. So I'm going to put parentheses around the first two pieces, and then put parentheses with a plus here, put parentheses around the second two pieces. So as you can see, that's what happened here. Putting parentheses here became these, and then putting parentheses here became these parentheses with that plus in the middle. So officially on our problem over here, we're going to end up with a 3x cubed minus 4x squared. And then to that, we're going to add the 9x minus 12. So we've taken nothing away necessarily from the actual problem. All we've done is grouped them differently, which is completely fine and doesn't change the problem. So then we're going to do two problems in one. So we're going to kind of just look at this left side here and ignore the right side, and we're going to say what's alike in these pieces and take it out. So again, we're ignoring that right side for a minute. So we just take a look at the numbers 3 and negative 4. Turns out that the only thing between 3 and negative 4 that's alike is 1, and so you can write it if you would like, but it's really not going to change that it's just a 1. And then x squared and x cubed, remember that we're looking for the lowest power of that to come out, so in that case x squared will be removed. So officially, again, just sticking with this same side, we now have 1x squared and then our leftovers. So if I divide a 1 by 3, I'm left with a 3. Sorry, 3 by 1. If I have a cubed and a squared, I'm left with an x. The minus 4 divided by 1 is going to be just the negative 4, and then those x squareds cancel. I'm not a huge fan of putting these 1's out here, so I'm going to take that away, but all we see now is that there's an x squared that potentially, to get back up to the top, we would just distribute back in. Then we move on to the other side, and so now we're trying to find out what is going to come out of these pieces. Just going to find another color, orange. Alright, so I'm finding out what can divide into 9x and then also 12. Since there's no variable in both of them, it's just going to be a number. And looking at each of the possibilities, for instance, listing out the factors of 9, we've got 1 and 3 and 9. And so the only thing that can divide also into 12 from there is a 3. If you're not the best at factoring, you can always just take your calculator and start dividing by all the numbers. So 9 divided by 1, 2, 3, and see which ones actually get a whole number. Alright, so 9x divided by 3 and negative 12 divided by 3 leaves us with a 3, yes, but then the leftovers. So 9 divided by 3 is 3, and the x comes along. And negative 12 divided by 3 is negative 4. And so now we have our two groupings. Now this is where it's going to get a little fancy, and hopefully you can see in this diagram up here how it works. So notice that in this parenthesis and in this parenthesis, oh my gosh, they're the same. That's what's happening here. They're saying, okay, now that you have done a GCF for each piece or each section, you're going to do a GCF for the entire thing. So we're going to take the 4x minus 3, or this 4x minus 3, and we're taking them both out to the front. So we're just doing a very, very large undistribution. The way I like to think about it, actually, instead of all of these terms, is let's say that we, whatever it happened to be, we're going to call it a yellow box right here. Okay, so let's say that that was a y or an x, or I don't know, whatever the yellow box happens to be. If it wasn't all of these terms and symbols, we could just take as much as we are already doing, that piece out front, and then we'd just have yellow box times our leftovers of x squared plus 3. Okay? But it turns out that the yellow box is not actually like a box, and so we are going to be able to replace that yellow box with the idea of that thing in parentheses. So I'm going to erase these pieces. And so now we're going to say that that yellow box, which is actually 3x minus 4, is going to come out front. So this piece is out front, this piece is out front. And so if those go out front, what's left over? An x squared and 3. And so this is the completely factored by grouping process of unfactoring something that is 4 terms long. So factoring by grouping is always going to be working with 4 terms, and it's very much alike with what we were doing with GCF. It's just a lot of them. So again, this is kind of, it's quite a growth of what we have here. So just start with what is alike in both of them and divide it out, and that's kind of what we're doing here. This one down here, you can either use our skills from the other day when we were distributing and using boxes, or you can, at least that's what I would do, so box these out and then match. And then this last piece here, the more you do it, the more it makes sense, okay? So just follow the steps each time, group them, what's alike in both of them, take that out, and then again, it's always going to be that this thing inside of the parentheses is the same. And so if you don't get the thing that's the same, go ahead and reevaluate. Maybe 3 isn't actually the GCF of this. Maybe it's actually 6, and so that's why you're kind of missing this being the same as this. Okay, so it's always going to be the same, and then you take it out front and get your leftovers. Alright, ultimately if that doesn't work out, you can of course follow along with the video that will come with the assignment, and you can work through them with me.